in simpler terms, a function has to pass the vertical line test. Well, if you flip it across the y equals x line, then it should pass the horizontal line test. And let's jump in straight to logarithms. A logarithm is the inverse operation that undoes raising a base to an exponent. Using logarithms is a way to find an exponent to which a specific base is raised to obtain a given value. So this might seem a bit abstract. I pointed the important part out first. Undoes raising the base to an exponent. So what does that mean? Let's say we have a simple exponential function. So this exponential function is raising x to an exponent, raising 2 to an exponent. To do that, we flipped x and y. Remember, they're inverse functions. So there's a term called undoes raising a base. So what you do here is you take log base 2 over. So what this allows you to do is to cancel this out, because cancel this out and then leave with y equals log base 2x. So you can see that log is a tool to undo a base, and this method is really clearly used in solving many problems or solving many logarithm equations. And the function f of x equals log base b. X is the logarithmic function with base b. The logarithm is an exponent, and yeah, this. So let me just make it more clear. Again, that circle there is where it corresponds this x, but this corresponds with y. Because when you think about it, so what this means is 2 is raised. So you can see the blue part, the 2 is raised to the value over the equal sign, this y value is raised to that power. So if we want to transform this to exponential function, we would have y equals x. Or you say that this doesn't really look similar to, because y and the x are flipped, but because they are inverses, that's why they're flipped. So that's how you get you achieve switching from exponential to log and log to exponential form. And so let's see why this is, because I mentioned it earlier, but I never proved that would work out as one, work out as cancel. So let's just log base 2, what would that equal? Let's say it equals x. So remember this rule, the base part will equal the base of the exponent, so 2. So the exponent here will equal this value here, to the power of x equals something, right? It equals something. So that something would be this red part x, that would be corresponding with 2. So 2 to the power of what will equal 2? Well, we know it's 1. So if this, if you might notice how if this value is 1 raised to the y power, then that wouldn't make sense, right? But in the later, there's a hint to the next unit, which is properties of logarithms. What you do in this situation, you can move this to outside. So y times log is 2. So this would equal 1. 1 times y will equal y. So that is why that this works.